Greetings, I'm Professor Hobo, and welcome to another HOBOTECH News product review. I get approached all the time to review solar controllers, and I almost always turn them down because they're either obvious junk, grossly overpriced, or worse, both. However, HQST asked me to check theirs out, and I was very pleasantly surprised by the features, build quality, and low price they're offering. So today we're going to check out what is claimed to be one of the best bang for the buck MPP solar controllers on the market. But is it any good? Let's find out.
HOBOTECH.
First, this comes in 3 flavors: 20 amp, 40 amp, and 60 amp. This is the 60 amp version. Now, all 3 of course are MPPT controllers because I wouldn't waste my time testing junky PWMs. So let's go over some of the numbers. This 60 amp supports 12, 24, 36, or 48 volt battery banks. The 20 and 40 amp versions only support 12 or 24 volt batteries. The 60 amp supports up to 900 watt of solar at 12 volts, 1800 watts of solar at 24 volts, 2600 watts of solar at 36 volts, and a whopping 3200 watts of solar at 48 volts. The 40 amp supports 600 watts and 1200 watts at 12 and 24 volts respectively. The 20 amp supports 300 watts and 600 watts at 12 and 24 volts respectively. Now the 60 amp does support higher solar panel voltages, so this supports up to 150 volts of solar input. The 20 and 40 amp versions support up to 100 volts of solar input. Now the VOC is on every solar panel. It's the number that you look at to determine the max voltage that you can pump into one of these controllers. Don't go by 12, 18, or 24 volts. You have to go by that VOC number. This means if you add up all the VOC of the panels you plan to place in series, you got to make sure that total number does not exceed 150 volts on this controller. Now what about hookups on this? The 20 amp has 10 gauge terminals, the 40 amp 7 gauge terminals, and the 60 amp 6 gauge terminals, because of course the more power you put, the larger wires you need to use. Now all 3 models do have 99% MPPT tracking efficiency and a 98% peak conversion efficiency. Self-consumption is only 10 to 12 milliamps on the 12 to 24 volt models, and as low as 2 milliamps in 48 volt mode when you're running the 60 amp version. Of course, these all have load control built into it like just about every other solar controller. It allows you for running small loads directly off the battery and controlling it either remotely via app, via daylight sensor, or with a daylight timer. Now on to the features. There are 3 major features on these HQST controllers, and these are why I chose to do this review, is it's hard to find this feature set at this low of a price point. First, and very important to some of you, they support low temperature charging cutoff, meaning if you have an unheated lithium iron phosphate battery that does not have built-in low temperature charging protection, you can tell this controller to not charge them in below freezing conditions. This is a really big deal to a lot of folks that charge lithium batteries in cold weather conditions. And HQST even includes a remote temperature sensor in all 3 versions of this for that exact purpose. So this feature does not come activated by default, which means it is disabled. So unless you turn it on, it's not going to stop charging your batteries below freezing. So let me show you quickly how you turn it on. Okay, first thing you want to do is hold the gear icon. That takes you into the settings. You want to make sure you are on the Li or Lithium profile for this to work, because obviously you don't need it on other profiles. Continue to hit the gear icon until you see the word off.F. Now all you have to do is up or down arrow, turn that on, hold down the gear icon to get out, and when you're finished and you back out, you want to go through and make sure that your setting has taken, because I've noticed sometimes if you don't hit the buttons just right, it's not going to save your settings. So there it says on.F. That means that the low temperature protection is turned on. Now let's prove that the low temperature protection actually works. I do have some icy salt water here, and I have the probe inside. It's registering the temperature at 29 degrees. There it is. It says 29 degrees Fahrenheit, and it is not charging. It is not accepting a charge. In fact, even on the screen here, you see the little solar panel, there is no transfer of energy going to the battery. I'm going to remove the probe from the ice water, watch the temperature go up, and we'll see that the charging starts. You'll see this number tick up, and then the animation will begin. So all I have to do is get this to to warm up a little bit. Okay, as soon as we started warming it up, it says 42 degrees. The charging is now back. You can see the little animation arrow there. Let's just do this again. I'm gonna stir up the salt. Most of the salt is in the bottom of this. It didn't dissolve. We'll see if we can get it down below freezing again and get it to shut off. I notice it does take a few seconds for it to register the temperature and actually activate or deactivate the charging. Now obviously temperatures aren't going to drop this quickly in nature. They're at 28 degrees, so it does take about a minute for it to register that it's below freezing, and we'll shut off the charging. And there it goes. It just, as soon as I zoomed in, it stopped the charging. And like I said, that delay is not a problem in real life because the temperature's never going to drop that quickly outside or even rise that quickly outside. So a minute is more than enough time for it to stop charging before your battery gets destroyed. Next, these actually have the ability to parallel with each other and communicate settings and charging parameters. This means that you could buy the 20 amp controller right here today, and if you added more solar panels in the future, you can get another 20, 40, or even the 60 to add on to it. And by using a simple 6-pin RJ12, which basically it's a 6-pin telephone cable for those of you that remember telephones that you plug into the wall, it uses this as a data cable to communicate the settings together. And all of the solar controllers have this input on it. So all you have to do is plug the cable into both sides, but then you have to enable this setting, and this is not mentioned anywhere in the manual. It was really confusing to me. I wasted a bunch of time trying to get these things to talk to each other, but I went to their website and there's a video that explains how to do it, but it is not mentioned anywhere in their user manuals. Now, in order to activate the parallel feature, you have to do a special button combination. So first and third buttons, hold them down simultaneously, and it comes up with PR-0. 0 turns paralleling off. So what you want to do is use the up or down arrow to change that to a 1, press the gear icon. Now that should save the setting, but we need to go back in there and make sure, okay, it does save PR1. And then you need to do the exact same thing on the other one, PR0, change it to PR1, gear icon, and boom, we'll just double check. Okay, it is PR1. And now that you have paralleling turned on for both, and you do have the cable going between them, it will now communicate the settings from one to the other. Now there's an important thing to realize, that one of them is going to be considered the primary and the other one's going to be considered the secondary. Now the only way you can tell is by looking on the screen. So one of these two screens are going to have a tiny little icon in the upper right hand corner, and that tiny little icon so happens to be on the 20 amp model. Now this means this is the slave and the 60 amp is going to be the master. So any changes I make here are going to be automatically reflected over here. So let me demonstrate this. So let's go ahead and change it from lithium mode to gel, for example. Hold down the gear icon. Now you do have to wait a few seconds for the information to transfer over to this one. But let's go ahead and hit the gear icon. It says it's set to gel. And just to show you that I didn't cheat on that, it actually does send the settings over. We'll put it back to lithium. So wait a few seconds. Oh man, it switched it on me. Now here's something that I've actually ran into a few times before. There's a little bit of a bug where sometimes they'll switch on you. Now this one actually has the icon, which makes this the slave and this one the master. And I think it's because I changed the battery type. And I think that's what actually causes it to switch from slave to master. But anyway, I changed it back to lithium there. Give it a few seconds. It should show up here as lithium. Yeah, okay, and it is. Now, unfortunately, there is no way to force one or the other to be slave or master. It just seems to be random. I tried turning this one on first, then this one, setting parallel to that first, then this one, unplugging, replugging the cable. I spent probably 30 minutes trying to figure out, is there a little scheme that I could use to force it to use the 60 amp? Because it always seems to favor the 20 amp, and I don't know why that is. You'd think it would favor the largest model and use that as the master and this is the slave. But every time I hook these up, this will be the master first, and then after I make a couple settings changes, it'll switch to this and permanently basically stay there. So now it's going to be permanently set this one the slave, so you had to make all your changes on this one. And that brings me to the final feature that I liked about these. Unlike most solar controllers that require an external module for Bluetooth, It's actually built into the HQST models. That's the 20, 40, and 60 amp versions all have built-in Bluetooth. Now that does mean you need to know which one of these are slave or master when you're changing the settings via Bluetooth, because if you try to change it on the wrong one, those settings just won't take. They'll just be ignored. So you have to pay attention to that little icon so you know that, okay, this one's the slave, you need to Bluetooth to this one and change all the settings on this one, and then it'll automatically transfer over to the other one. Now what's cool about the Bluetooth, it means you can control the major settings and remote monitor your controller wirelessly via their app within Bluetooth range, which is about 30 feet. So let's take a quick look at that app. Now when you open the app, you need to go in and connect directly to the Bluetooth. Now the first one that says Charge Pro, that is the 20 amp, and then the one down here that says PV Charge Pro, that's the 60 amp. So since we know this is the master, that's the one we want to connect to. So you can see here it says real-time monitoring, gives you the battery state of charge and the voltage, gives you the amount of solar input, which right now is 0 because I don't have it turned on, gives you the battery voltage and the current, and the DC loading. Now you can store up to 300 days of historical data, so you can see on the screen it'll show you the maximum, minimum voltage, your charge rate, and everything else over the last 300 days. Now as for the parameter settings, you can just hit the parameter down here in the corner. This allows you to change everything in here, including the battery type and all your charge parameters, so you can go ahead and customize this as much as you like. And then this will allow you to change your boost voltage up or down depending on your needs. And then if you hit confirm, it'll actually automatically send those settings to both controllers. And that's really all there is to it. Now as for the other features, this does offer a nice LCD display with straightforward, easy to use buttons. You've seen me get through the menus pretty easily. And you can set this up without even using the Bluetooth app and not even tearing your hair out. Of course, it supports all battery types such as flooded, sealed, AGM, gel, and lithium iron phosphate. Now this will automatically jump a dead lithium iron phosphate battery, so if you accidentally kill your batteries at 3 o'clock in the morning, they'll restart automatically as soon as the sun comes up. These also offer a plethora of protections to protect this and your battery bank. Those would be typical overcharging, over discharging, overload, overheating, short circuit, and reverse polarity protection. HQST offers a 12-month warranty across their MPPT product line. Now, this wouldn't be much of a secret lab without a little bit of testing. There's not really a lot you can do with a solar controller besides pump power into it and see if it charges the batteries properly. So what we have right over here is my variable voltage charger, and I actually have another variable voltage charger over here. So I'm going to use this to pump power into this, and I'm going to use this to pump power into this. I have a completely dead, or almost completely dead, lifetime 100 amp hour battery behind me. That's going to allow me to pump the most power possible into the battery. So we're going to see, can I get 900 watts or close to 900 watts into that battery through my variable voltage charger going through the HQST 60 amp. This supports a maximum of 900 watts at 12 volts. Now I'm not going to test 24, 36, 48. This is just a demonstration to show you that it can pump in a lot of power. It does work in parallel mode. I've already done the pre-testing, so I can guarantee it's going to work. But I'll show you how it works. So unfortunately, it's kind of difficult to film both of these going at the same time, but I'll go ahead and angle this in such a way that you can see the voltage and amp that I'm putting in over here. So let's start with pumping the power in from this side, because this is going to be the big charger over here. Now this little 20 amp only supports 300 watts. Now I do have this set to 100 volts DC, and I'm going to allow it to put as many amps as it dang well pleases through the controller and into the battery. Now, one thing to note, when you're in parallel mode, you have to supply solar to both controllers. Right now I have 100 volts pumping in. You see this says 0 amps. Because until I turn this on, it thinks that solar is not being applied to both. Because these are set in parallel, they want to work together, therefore they both need some level of solar. Now, you can put 10 watts in on this one and 1,000 on the other one, doesn't matter. It just needs to be activated. So I'll turn it on. I have it set to 32 volts, which is its maximum. And now it's showing the green light on here that shows that it's solar charging. And boom, this green light just came on right before your eyes, meaning it's solar charging. Look at the voltage went way up. So now it's actually supplying 14.3 volts into the battery. And you can see down here, here we have it, 100 volts at 9.2 amps. So we're actually pushing 920 watts into the battery That's actually a little bit more than what it's supposed to do, which is a nice little overhead. It even tells you right here, 900 watts is the maximum. So I don't know if you can read this or not, but it does say 900 watts is the maximum for 12 volts, 1824, 2636, and 3200 for 48. Maximum charge current 60 amps, maximum load current, which is coming out of here, 20 amps. Now that we're charging, let's go through this. Now there is a slight backlighting to this, so you can use it at night and actually see what it is. Okay, there we go. We have our 100 volts going in. You see it's got a little animation going there showing you that the solar is going into the battery. So it actually even tells you the current temperature of the sensor, which is room temperature right now. It's telling you how many watt hours we've pumped into the battery. It's telling you here the actual amps we're pumping in. So we're not pushing 60 amps, but we are doing about 43 amps. Now here's one of the things I can do to slightly cheat a little bit. I'll go ahead and I'll change the voltage in the controller to allow me to pump in more power. So I'm going to go into parameter settings and change the boost voltage to 15 volts. Now it's actually pumping 15 volts into the battery. So let's see, we should actually be back in a pretty good place amp wise. There we are, we're pumping 62 amps out of a 60 amp controller. And look, we're doing 970 watts of charging. That is fantastic. So this controller over here, let's go ahead and crank the amps all the way up and see what happens. We're getting close to that magic 300 watts, aren't we? We're actually at 310 watts because you multiply amps times volts. So there you have it. I'm pumping in 900 from one controller and 300 from another. So I'm actually pumping 1200 watts or close to 100 amps into that battery, which is its maximum charge rate anyway. Now I don't want to do this for very long because the cabling I'm using, you can see here, is very flimsy and I'm just using battery clamps. In fact, I can feel the heat through there. Let's go ahead and nix this test before I start melting cables. But that's proof of concept. Yeah, I can smell things melting. I just set this stuff up temporarily. You have to understand, I work on several projects at once. So I clear this table, put something else, do another video, bring this stuff back, hook it back up, because I'm working on several videos at once. A lot of times I'm just using flimsy cables just to demonstrate, because I'm only running it for a few seconds. Now obviously you're not going to use battery clamps and thin wire like this on a 60 amp controller. It will melt and probably cause a fire. So don't go by my example. Don't be using battery clamps and cheap cables. Use the best wire you can afford. Look in the manual. The manual will actually tell you what gauge wiring you should use. And that's a big problem because I've actually personally known several friends of mine who wire up some big monster 60 amp controller like this using little skinny wires, and they wonder why their performance suffers or their inverter turns on or off, or they smell smoke or things melt or fuses blow. It's because they're not using the proper gauge wiring. So make sure you factor this into your budget. Don't get skimpy on the wire. Use pure copper wiring, none of that aluminum coated crap. Use good wiring when you're passing a lot of power through. And trust me, you will not regret spending a little extra money on good cabling. Okay, here's the part you've all been waiting for, and this is where things get good. First, if you've never heard of the brand HQST before, they've been around since 2015, and the brand is headquartered in California. Now, do a quick little Google search. You can find there's a major brand affiliation with HQST, but they don't want me to talk about it. And the reasoning's pretty obvious because they don't want to undercut themselves because the prices on the HQST compared to that other brand are utterly ridiculous. The retail price of the 20 amp, which is the smallest of the three, remember it still has all the features that I mentioned. It's just less output and can only do 12 or 24 volt battery banks. This thing is only 99 bucks. Currently on sale for 89 bucks as of the filming of this video. Now the 40 amp, which they didn't send me, retails for 139, but it's currently on sale as of the recording of this video for 126 bucks. The 60 amp, which is my favorite because it supports 48 volt battery banks, retails for 229. Now that might sound like a pretty huge price bump, but remember the 60 amp supports 150 volts of solar where the other ones support only 100. It also supports 3200 watts of solar compared to 1200 watts for the 40 amp. And it also supports that magic 48 volt battery bank versus the maximum 24 volt battery bank that the 20 and 40 amp controllers support. Once you factor in parallelability, built-in Bluetooth, low temperature cutoff, at this price, I personally spent over 800 bucks for a similar size Victron controller that does all the same stuff. Yes, the Victron app is much, much better than the app that you can get with the HQST, but is it 4 times the price better? I'll leave that for you to decide. I just know in this day and age with the economy the way it is, people just aren't spending money on the good stuff anymore. They are looking for the cheapest things that do the job, and this is really going to be the cheapest thing that can do all this. You might be able to find Chinese knockoff brands on Alibaba or one of those rip-off websites where they're there to steal your credit card information, but you can actually buy this direct from HQST, which is a reputable company that's been in business, like I said, since 2015. Their products are all over Amazon. I own several of their solar panels actually, and all their stuff has always been pretty good. I've never really had anything of theirs fail that I can think of. Oh, and I almost forgot to mention that viewers of HOBOTECH will be scoring an additional 10% off of these already silly low prices for a limited time by using the discount code below. So if you're interested in any of the HQST controllers, the link and discount code will be in the description of this video below. I'm also going to put a link at the bottom of the screen that you can type in manually, or you can scan this QR code over here on a mobile device. It'll take you on over to the HQST store page where you can check out their fantastic line of best bang for the buck MPPT controllers. Thanks for watching. If you learned something today, don't forget to give me that thumbs up below. And if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe, and clean my litter box. RV Golf Guy, Brian Blue, Bruce Johnson, Jason Sirocco, Steve Eisen.